Hello, this is simply about networking protocols, and today I'll tell you about VxLAN+EVPN, also known as integrated routing bridging, and there are symmetric and asymmetric modes of operations. There is no standard for this particular networking function. This is protocol's interoperability, where each protocol is working according to its own standard. In this video, I'll provide you intro, important for understanding of the topology, why at all we need this complex configuration, how it works, and I hope after this intro you will easier understand those schemas that you see in the internet and descriptions of the VxLAN+EVPN working for in internet and for your particular vendor. And also I'll describe simply step by step how symmetric mode works, asymmetric mode works, and where is EVPN there. So let's take a look on this schema. Well, as you remember from the VxLAN video, in case we have all the interfaces part of the VNI of the same segment and all devices configured in the way that they sending traffic to those interfaces, that this traffic will be treated as a part of the VNI. No problems at all. Standard VxLAN as it designed, working in this mode, processing this traffic correctly, and we don't need any additional or fancy configuration. Then, as you understand, additional configuration we need only when interface is not the part of the tunnel VNI. In the asymmetric model, we have that one interface is not the part of the tunnel VNI and second is always egress. But probably let's take a look on the symmetric schema. It's easier. On symmetric schema, all interfaces are not the part of the tunnel VNI, neither devices behind those interfaces. We can treat those left and right part as some additional VNIs. We have some left VNI, we have some right VNI, and we have some tunnel VNI that we need to send traffic through. Those can be not VNIs. Those can be just interfaces, any interfaces that could correctly proceed L2 and L3 traffic. For my ease, I will call them VLANs. But again, those are not the part, not participating in tunnel VNI. So let's take a look on the symmetric schema, symmetric mode, step by step. We have a tunnel VNI, we have interface on the left, we have interface on the right, and we have some devices that need to transmit the traffic. We're receiving traffic on device on some interface, and in order to transmit it further, we need somehow to pass it to another interface, to the tunnel VNI. This is where routing appears, routing. We routing this packet into VNI because next hop for this type of packets will be configured in our routing is device on the VxLAN tunnel egress on the tunnel end, device on the tunnel end, next hop in the symmetric RB. Then packet or traffic being routed gets into VNI. There are applied all the VxLAN configurations that you already know. This is the standard, nothing additional or fancy. Packet being wrapped to be sent through the tunnel, being sent through the tunnel, reaches the egress of the tunnel, unwrapped. Since this device was configured as next hop, device start processing this original packet, routing it, checking into the routing table and routing it into egress interface that is not the part of the tunnel. And this packet is being sent to actual device that is supposed to process it as it was planned by the source. In reverse direction happens all the same. So both in lefts, from the left to the right, it goes to the routing tunnel routing interface, and vice versa, it goes to the routing tunnel, routing interface. I think this is why it's called symmetric model, because on the both side, both participating interfaces or all participating interfaces are not the members of the tunnel VNI. Again, as you remember from the VxLAN video, specification tells that VxLAN tunnel is semi-directional, unidirectional, and some vendors treat it seriously. So it is possible to have following model when we have two tunnel VNIs between devices, one to transmit traffic east-west, second to transmit traffic west-east, but again, none of the interfaces that are participating in this functionality are not the members of the tunnel VNIs, except VTEPs. That's it about symmetric. Asymmetric model assumes that interface and, well, devices behind this interface are part of the VNI, always on egress. In this schema, it means that green VNI transmit traffic to the left because egress interfaces are part of the VNI. Three bottom VNIs transmit traffic to the right because egress interfaces are part of the VNIs. Again, those interfaces could be any interfaces that could correctly process traffic L2, L3, and always egress interface is the part of the tunnel VNI, ingress interface is not. Here we need additional functionality on the ingress. How it works? We're receiving a packet that needs to be transmitted somewhere here. Then this packet sent for the routing. Next hop for the routing, unlike symmetric model, is actual device in some VNI that's supposed to process this traffic. This is how we're selecting which tunnel VNI needs to be selected. We are routing packet to this tunnel VNI according to the next hop. In this tunnel, eventually all VxLAN standard operations applied, so it's being wrapped, transmit to the tunnel end, unwrapped, and simply transmit to the destination device in the VNI. No additional, because we already know that next hop is here. In reverse direction happens the same. We're receiving packet that needs to be sent somewhere there, looking for the routing table. The routing table displays that next hop is somewhere there. We are routing packet to the appropriate tunnel VNI. In the VxLAN tunnel happens all the magic of the VxLAN. It's being transmitted, unwrapped, and forwarded to the appropriate device for the further processing, as was designed by the source. That's it. So asymmetric model differs from symmetric model in the way that egress interface is the part of the transmit VNI. So we have routing only on ingress, not on egress. And question appears, where is EVPN here? EVPN is here managing routing data and routing operations. Since VxLAN is designed to process not only L3 traffic but L2 traffic too, and L2 traffic doesn't have IP information, we need additional feature that allows us routing based on the MACs or VLANs. This is where a VPN appears, and it needs to be configured to allow routing to the tunneling VNIs. So in case of symmetric model, it manages both routing table to route it bidirectionally. In case of asymmetric model, it manages routing table to route packets to appropriate VNIs on the west and to appropriate interfaces to the east, and vice versa. That simple. Thank you. Have a great day.